One, two, three. Hi. Okay, so today my group will talk about process concept. But before that, let me introduce my teammate. My name is Ray.
Fitri.
Alia.
Akram.
Okay, so the first one will be Fitri. She will talk about,
Process concept.
and then Alia,
Proses scheduling.
and then me on operations on process, and then the last one will be Akram.
Interprocess Communication. Let's start.
Mana yang terus?
Edit.
Process concept. In process concept, there is a unproprietary system execute a variety of program which is its base system, job and time share system, user program or task. There are multiple parts which is its program code called test section. Current activity including program counter start containing temporary data, data section containing global variables, heap containing memory dynamically allocated during the run time, and program is passive entity stuck on this executable file. Program become processed when executable file loaded into memory. Execution of program start via GUI mouse click. Command line entry of this name. One program can be several processes. In a process state, there are 5 chain state when process executes happen. New state, running state, waiting state, ready state, and terminated. Process control block. In process control block, PCB information associated with each process that we call test control block. There are process state, program counter, CPU register, CPU scheduling information, memory management information, accounting information, and input-output status information. Thread. In thread, each process have single thread of execution. In consider have multiple program counter per process. Multiple location can execute at once. Thread is a multiple threads of control. All information in thread will save in PCB process control block.
Objective process scheduling are to maximize CPU utilization. Process scheduling also quietly switch process on CPU for time sharing. Moreover, process scheduling is to maintain the scheduling queues. There are 3 types of scheduling queues. First, job queues. Job queue is set of all processes in the system. Second, ready queues. Ready queue is set of all memory processes residing in memory ready and waiting to execute. Third is device queue. Device queue is set of all processes waiting for an I/O device. Process scheduler is needed advice to objective of process scheduling. Process scheduler select an available processes for next execution on CPU. There are 3 types of scheduler. First scheduler is long-term scheduler or called as a job scheduler. Long-term scheduler select which processes from job queue should be brought into ready queue. Long-term scheduler control the degree of multi-programming. Second scheduler is short scheduler of CPU scheduler. Short-term scheduler select which processes from ready queue should be executed and allocated on CPU. Third scheduler is mid-term scheduler. Mid-term scheduler can be added if degree of multi-programming needs to decrease. Queuing diagram. A common representation of process scheduling is queuing diagram. Queuing diagram represents queues, resources, and flows. 2 types of queues are present: the ready queue and set of device queues. Once the process is allocated the CPU and executing one of several events called a queue. First event I/O request, when the process call issue an I/O request and then be placed in an I/O queue. Second event, when time slice expired, when the execution time for the process has ended, the process will be brought back to ready queue. Third event, for a child, when the process call create a new child process and wait for the child termination. The process will be brought again to ready queue and waiting to be executed in CPU after the child process terminated. Last event, wait for an interrupt, when the process could be removed forcibly from the CPU, result of an interrupt and be put back in the ready queue. Context switch, when CPU switch to another process, the system must save the state of the old process and load the saved state for the new process via context switch. Context of process representation in PCB.
There are many operations that can be performed on processes. Some of these are process creation, process preemption, process blocking, and process termination. These are given in details as follows. Process creation. Processes need to be created in the system for different operations. This can be done by the following events: user request for process creation, system initialization, execution of a process creation system call by a running process, and batch job initialization. A process may be created by another process using fork. The creating process is called the parent process, and the created process is the child process. A child process can have only one parent, but a parent process may have many children. Both the parent and the child processes have the same memory image, open files, and environment strings. However, they have distinct address spaces. Process preemption. An interrupt mechanism is used in preemption that suspends the process executing currently, and the next process to execute is determined by the short-term scheduler. Preemption makes sure that all processes get some CPU time for execution. Process blocking. The process is blocked if it is waiting for some event to occur. This event may be input-output, as the input-output events are executed in the main memory and don't require the processor. After the event is complete, the process again goes to the ready state. Process termination. After the process has completed the execution of its last instruction, it is terminated. The resources held by a process are released after it is terminated. A child process can be terminated by its parent process if its task is no longer relevant. The child process sends its status information to the parent process before it terminates. Also, when a parent process is terminated, its child processes are terminated as well, as the child processes cannot run if the parent processes are terminated.
I want to tell you about interprocess communication. It is the mechanism provided by the operating system that all allows process to communicate with each other. This communication could involve a process letting other process know that some event has occurred or the transferring of data from one process to another. A diagram that illustrates in the process communication is as follows. Approach to interprocess communication. The different approach to implement interprocess communication are given as follows. Pipe. A pipe is a data channel that is unidirectional. Two pipe can be used to create a two-way data channel between two processes. This use start, input and output method pipes are used in a POSIX system as well as Windows operating system. Socket. The socket is the endpoint for sending or recurring data in a network. This is true for data sent between process on the same computer or data sent between different computers on the same network. Most of the operating system use socket for inter-process communication. File. A file is a data record that may be stored on a disk or accurate on demand by a file server. Multiple process can access a file as required. All operating system use file for data storage. Signal. Signals are used in inter-process communication in a limited way. They are system messages that are sent from one process to another. Normally, signals are not used to transfer data but are used for remote command between processes. Shared memory. Shared memory is the memory that can be simultaneously accessed by multiple processes. This is done so that the process can communicate with each other. All POSIX system as well as Windows operating system use shared memory. Message queue. Multiple process can read and write data to the message queue without being connected to each other. Messages are stored in a queue until the recipient retrieve them. Message queue. Queue useful for inter-process communication and are used by most operating systems. A diagram that demonstrates message queue and shared memory method of inter-process communication is as follows.
One, two, three.
Lupa pula. Oh. Study bye.
Tadi.
Buat lawan lain dulu.
Tadi.
Lama.
Ni orang dah. Hai.
Tak nampak tu.
Hai.
Hai.
Kap.
Tak kuat sikit.
Cakap.
Dari sebelah. Nah. Iyalah.
Fitri. Bertapuk pula dia.
Apa benda ya?
One program can be several processes.
TB. Dah. Kalau besarkan skrin tu tak boleh.
Oh, besar
Besarkan ni,
screen.
besarkan ni.
Laminated.